there, fellow developers. Welcome to today's video where we dive deep into a game-changing topic for software development, proper logging. If you've ever found yourself scratching your head over mysterious bugs or struggling to understand your application's behavior, this video is for you. We'll explore what logging is, why it's absolutely crucial for your projects, and how can you implement rock-solid logging in your ASP.NET applications using Serilog. Before we jump into the nitty-gritty, let's talk about three key concepts that form the backbone of robust, maintainable, and scalable applications. Think of logging as your application's diary. It records events, errors, and important information about what's happening under the hood. Logs help you debug issues quickly and provide insights into your application's behavior. Without proper logging, troubleshooting becomes a guessing game. With proper logging, we can monitor application behavior, capture application events, and have insights into performance. Traceability. This is all about tracking the flow of your application's process. Traceability ensures you can follow the lifecycle of requests or commands from start to finish. It's especially helpful when working with distributed systems or microservices where multiple components interact. With proper traceability, we can track application requests, send source identification, facilitating debugging, and enhancing reliability. Metrics. Metrics give you measurable data about your application's performance. Things like response time, error rates, or resource utilization. While metrics are vital for monitoring and optimization, metrics help you to make data-driven decisions, and by leveraging metrics, developers can enhance user experience through targeted optimizations based on real data. Today, we are focusing on logging, which provides the rich context that brings your metrics to life. So let's roll up our sleeves and dive into implementing proper logging in ASP.NET project using Serilog. Let's walk through a practical example using ASP.NET 8 project with C#. In our project, we have two crucial components for logging exceptions and tracking application flow. First, Global Exception Handler. This class is our central hub for handling unexpected exceptions throughout the entire application. It inherits from iExceptionHandler and is registered in our dependency injection setup file. As you can see here, I have used service.addExceptionHandler. This approach allows us to format errors based on their type. For instance, if we have a custom handle unauthorized access exception method that formats unauthorized access exceptions with a specific title and type. Before returning these nicely formatted exceptions to the user, courtesy of the problem details class, we log it in a way that's meaningful for us as developers. The most important aspect of proper logging is that you must adhere to a structured logging format. A suitable log should consistently include essential information regarding what went wrong, such as date and time, log level, message, and context. And bear in mind, you shouldn't log sensitive data. For example, if there is an unauthorized access, I will log it as a warning to maintain a record of the event. This might require further examination or action. Additionally, if there is an unhandled exception, I will log it as an internal server error and provide an appropriate error message after documenting the exception. Another important place is the logging behavior class. This class is where the logic happens for request logging. It inherits from iPipeline behavior, and because we are using the mediator library, this class acts as a pipeline that invoked for each request. For every request, the handle method kicks in. We use a stopwatch to measure the time spent on each request and log information like the command name and timestamp. After the request completes, we stop the timer. If the request took longer than a second, which could signal a problem, we log a warning with the request name, timestamp, and duration. If the request is successful, I will log an information message stating that the request was successful. However, if there is an error, I will log an error message that includes the error name, the date and time, and details of the error. Please note that I have added an @ symbol to the beginning of the error message. I chose this style because I'm using Serilog. By using this format, Serilog will save the login in a structured manner, allowing it to serialize the error message. This makes it easier to query and extract more information from the log files. If you're using third-party libraries such as Sec to query all those logs, it will be easier to find the specific error you're looking for. Now let's talk about how we're implementing this logging using Serilog. To use Serilog in your project, you'll need to add the serilog.asp.NET Core NuGet package. We've also added serilog.things.azure app to store logs in Azure App Insights. In the program.cs file, we set up Serilog like this. By calling the builder.logging.clear providers, we will clear the default or previous logins providers. Then by calling builder.host.serilog and rest of the configuration, we instruct Serilog to read all the configuration from settings.json file. If I open the app settings.json file, you can see that I have removed all the default login configuration and replaced them with Serilog settings. In the initial section, I have defined my login things using this configuration, console and file. I want to configure the login systems so that the logs are stored both in console and as a file. I have defined the default log levels for different environments. For production, I have set the default log level to information, while for Microsoft and system logs, I have adjusted to warning. In contrast, the default log level for the development environment is set to debug, allowing for more detailed logging during development. I have defined the locations where the logs will be stored. For example, I have specified that I want to save logs in the console using a particular format. Additionally, I set up another output for saving log files. The log files will be stored with the file name template specified as logs and this format. In the output template, I also defined the format for the log output. Then I added the Azure App Insight configuration for storing log files by adding this configuration. Let's see this in action. I expect when we run our application and create a new book with an empty title, which violates our validation rules, we'll get a 400 bat request error. But more importantly, we'll see detailed logs in both our consoles and log file, formatted exactly as we expected in our Serilog configuration. Hence the identical exceptions. This confirms that Serilog is correctly logging to both the console and the log file, which is expected. I encountered a 400 exception that indicates the title must not be empty. As I checked the console, I see the same error message. Additionally, when I review the log files that should have been created, it contained behavior. Furthermore, it is using the specified format we configured. To clarify further, I will set a breakpoint and run the application in debug mode. This time, I will repeat the same scenario by sending a post request to create a book with an empty title. As you can see, I received the command to create the book. I started the timer, but since I set a breakpoint, the process took longer than expected. That's why it indicates that the request took longer than 1 second. Because the title was missing, I will log the necessary information, including the command name, date and time, and the error message, which in this case is title is required. An important tip to consider is using the result pattern for handling business validation. For instance, instead of throwing an exceptions when the title is empty, I treated this kind of business validation as an error. I prefer to use the result pattern to return a Boolean value, true or false, for validation, rather than throwing exceptions. This approach can help avoid the performance overhead associated with exceptions, which can slow down the application. Let's examine the base request handler file. In this file, I will execute all the validations using Fluent validation. For example, in the case of the create book command, I have defined 2 validation rules. I will run all these rules, and if there are any issues or errors, I will extract those errors and return a failed result. I've implemented a result pattern in this project instead of throwing exceptions which can slow down the application. I'm returning a result object, in this case, a failure object. This approach allows me to log the application's behavior without causing performance issues. However, it's essential to have proper logging in place, which I have implemented to ensure that nothing is overlooked. Takeaways: logging is essential for debugging and understanding your application's behavior. Using a global exception handler to capture unexpected errors and log them effectively. Implement logging behavior with mediator to log command execution details and message performance. Leverage Serilog to store logs in multiple formats, console files, and cloud services like Azure App Insight. Use structured logging for easier querying and analysis of your logs. Consider using result pattern for business validation instead of throwing exceptions, which can slow down your applications. You can use domain-validation.net NuGet package. And there you have it, folks. You're now equipped with the knowledge to implement robust logging in your ASP.NET applications. Remember, good logging practice can save you hours of debugging headaches and provide invaluable insight into your application's behavior. Thanks so much for watching. If you found this video helpful, don't forget to smash that like button and subscribe for more tech tutorials. Drop any questions or suggestions in the comments below. Until next time, happy coding.